We're going to look at the path of power through a clutch used with the countersunk flywheel. The on-highway industry typically uses a flat flywheel now, the countersunk, older vintage. However, the function of the two clutches is identical. The only real difference is a minor change in the path of power and a few of the internal parts. I'd like to use this picture. Now this is a side view cutaway of a clutch assembly bolted to the countersunk type flywheel. And what I find helps is putting color to this. What I would recommend is if you could pause the video, take a screenshot of this page and print it. From there, grab a couple of pencil crayons and come on back and we can start putting some color to this thing. I'm going to use orange for anything that is spinning at engine RPM. Now the first part in the path of power is the flywheel itself. It's bolted to the crankshaft, so there can be no speed difference. Flywheel first. Next in the path of power, we've got two parts. The clutch cover itself is bolted directly to the flywheel. As well, the countersunk flywheel uses these drive pins to drive the intermediate plate. So first is the flywheel. Flywheel drives clutch cover and intermediate plate. The clutch cover drives the pressure plate. And to show you how that's done, this is a picture of the clutch assembly that would be used with the countersunk flywheel. You notice in between these orange marks, right here, there are drive slots in the clutch cover itself. Now those drive slots are what force the pressure plate to rotate. The pressure plate is also able to move back and forth slightly as required when the clutch is engaged or disengaged. Again, flywheel drives clutch cover and intermediate plate. Clutch cover drives pressure plate. The pressure plate drives the clutch discs. Okay? Or actually the pressure plate combined with the intermediate plate and the flywheel drive the clutch discs. Now the clutch discs are in a different color. Used green, you can use whatever you need, because the clutch discs can either be going 0 RPM, so stationary, or they can be going engine RPM. This is a dry type clutch. There is no oil inside of it. These friction discs are not designed to be running at somewhere between 0 and engine RPM for any real length of time. So again, flywheel drives clutch cover and intermediate plate. Clutch cover drives pressure plate. Pressure plate drives the discs, and down through the clutch hubs is where the transmission input spline shaft would actually spline in. Here's a picture of one sample of a clutch disc. You notice in the middle you've got the splined hub, and around the outside we've got the friction material. Friction materials can be woven, they can be organic, they can be ceramic buttons, just different variations depending on torque loads.